going to now start solving exponential equations using logarithms. And mostly today we're going to work with the common log, which is in base 10, which is relatively easy to work with. So if you're looking at question A right now, 100 to the x equals 600, or excuse me, 10 to the x equals 600, we don't have a way of rewriting these in the same base. 10 to the x is, I can't rewrite that any other way. I can write it as 2 times 5, but that's not a single base as your factor there. Same with 600. I can't rewrite 600 as a power that has the same base as 10. And when we run into that, then what we have to do is we start using more algebraic techniques with logarithms. So we're still using properties of logs. So one of the things we're going to do is in mathematics, if you wanted to, you could add a number to both sides of an equation. You could square both sides of the equation. You could divide both sides of the equation. And as long as you're balanced, you're not breaking rules. So in this particular case, we're going to take the logarithm of both sides of the equation, and then we're going to use log properties, right? So we're going to set it up. We're going to take log, this is the common log, so it's in base 10 of, and then it's going to be 10 to the x equals log of 600. So now that I have that set up, oops, sorry, 600. And then it's 10 to the x, okay. So on the left side here, you can view this problem two different ways at the moment. So one thing that we have to remember when we're using the common log is that the common log is in base 10, and we don't write 10 in the subscript there, right? It's just understood that it's in base 10. So you're looking at the inverse operation that we learned yesterday right now. Log of 10 to the x, the base of the logarithm right here, 10, is the same as the base of the argument. And whenever you have that, then that's an inverse operation, and you're just simply left with the exponent. So in this case, the left side of this entire equation simplifies to just x. All right, so x equals log of 600. X is isolated, log of 600 is as far as we can take it. This is the exact answer, okay? And then we can approximate these values as well. We'll talk about the approximation in a second. Alternatively, for this one right here, if you want to look at it from a different perspective, meaning not necessarily that inverse operation, we can use the same idea with the power, right? So we still take the log of both sides. But right now you're less worried about this 10 being the common log, right? It's still the common log, but you don't have to really focus on it. But what you do want to remember is that anytime a logarithm has an argument with an exponent, we can rewrite this, or we bring that exponent out and make it a coefficient of the logarithm. And this strategy here is commonly used when you're solving this type of equation. So now we have we have x times log of 10 equals log of 600. And we're trying to isolate x at the moment. So again, it's coincidental at the moment because this log 10 right here on the left, the x times L log 10, that log 10 that simplifies to 1, right? If you remember, 10, so that logarithm is asking us base 10 in blue raised to what exponent is 10? That would be 1. So this whole thing simplifies to 1. And if you recognize that now, then turn it into 1 and x is isolated. If you don't recognize it now, then the next thing you're going to do here is you're still trying to isolate x, so you would divide both sides by the log of 10. Leaving you with x equals log 600. 600, whoops, log 600 divided by log of 10. This particular example, we would need to simplify further because the log of 10 is 1. And this is going to break down to the exact same answer, log of 600. So there's a few ways that you could approach these. Sometimes one way is more efficient than the other. You just need to look at it. This is I don't want to say that the format of this answer is rare, but often you're going to be left with a fraction, meaning it'll be something similar to this expression here, where this denominator doesn't necessarily simplify into an integer value or a numerical value. And if you wanted to approximate this value, what you're going to do is you're going to take your scientific calculator and search for the log key on your scientific calculator. It should be near your exponent key, and it should just say log. So right now, most of your calculators are programmed to work with the common log and then what we call the natural log. Right now, the common log. So if you see the log key, it should pull up in base 10. Occasionally, if you have a newer scientific calculator, graphing calculator, excuse me, especially the TIs, it'll allow you to put a base in the logarithm, but most don't right now. So, this is Desmos. I have to move over to the function tab here to find my log key, and here it is. So I'm going to hit log. Now my calculator here gives me grouping symbols to type the argument inside. Most scientific calculators don't group it, so if you're dividing a logarithm by a logarithm, you always want to close that grouping symbol, but in this case it's just log of and then 600. And then I get 2.7781. So approximate value here is x. We're not asked to round at the moment, but we are asked to approximate. So x is approximately 2.778 here. Both are equivalent. All right, we can do the same thing up above. All right, 5 to the x equals 41. So I'm going to take the log of both sides. So I'm going to take log, common log again, right? Rewrite it. So I have 5 to the x, and then I have 41. So in this case, the logarithm's in base 10, but the argument is in base 5, so there's not much I can do. So I have to use this power property where I bring this variable out, that exponent, right? So now I'm dealing with x times log of 5 equals log of 41. I'm trying to isolate x, so in order to do that, I'm going to divide the log of 5 on both sides of the equation. It simplifies to 1 right there, so now I'm dealing with x equals, in the numerator, I have the log of 41, and in the denominator, I have the log of 5. This is the exact answer. It doesn't simplify any further than that. That's what we have. And if I wanted to approximate this, I have to put it in my calculator, right? So I think my screen, I don't know where my calculator went. So what we're going to do here, hoping it's recording the calculator, is go to my next line here. So I go to my log, right? So log of 41. Make sure my group is closed, right? And then you want to hit the divide button. If you hit the divide button before you close that group, your calculator is going to divide 41 by the next thing you type, and that's not what you want. You want to make sure you close that group, then you hit the divide button, and then you're going to hit log of, in this case, 5. So 5, close my group, equals, and that's approximately 2.307. And now we're solving exponential equations with logarithms. All right, 2 more. 3 to the x equals 20. Right, same concept here. Take the log of both sides, so now I'm at log of 3 to the x equals equals log of 20. Pull my exponent out, x times log of, you don't need that dot, 3 to the x, or log of 3, excuse me, equals log of 20. And we're going to divide by log of 3, both sides. That's going to leave me with x equals the log of 20 divided by the log of 3. And that is my exact answer. And then we can approximate this as well if necessary. The left or the right part D, there's a few things you could do here if you really wanted to. And what I mean by that is, you could, I probably wouldn't in this case, but you could 0.8 to the second power to the x. You can kind of deconstruct that power this way if you like, right? 0.007 here. And then raise 0.8 to the second power. And there's nothing wrong with that. Personally, I would probably just jump into it as is right here. Meaning I'm just going to start with taking the log of both sides. Right? So we'll do a log of 0.8 to the 2x equals the log of 0.007. Then, even at this point, you could address that 0.8 to the 2 to the x, or you can easily just pull this out. Right? So now we're dealing with 2x times the log of 0.8 equals the log of 0.007. I can divide both sides by the log of 0.8, or you could divide both sides by 2 log 8 at the same time, because multiplication is commutative, right? 2 times x times log 0.8. So just divide it by 2 log 8. Oops, not equals. 2 log 0.8, excuse me. And then it simplifies to x equals log 0.007 divided by 2 times the log of 0.8. So this is your exact answer. I know it has decimals in it and there's a fraction involved, but again, if we had to approximate this value, we're going to have to throw it in a logarithm in the calculator here, right? So let me pull this back up here. Where'd it go? So I'm going to type log. I'm going to go log 0.007. Close my group. Divide. Make sure you close that group. Log. And then we're going to go 2. Oops, not 2. The 2 was first, excuse me. So it's 2, and then it's log 0.8 or 0.8. It wouldn't matter either way. And that's giving me 11.118. We want the exact, so shoot for that exact answer there every time. And I believe that takes us to the end of that concept. Yeah, and then there's your assignment. Okay.